Hello friends, till now we are knowing that how to find out ordinary solution and how to find out ordinary solution so ordinary point and singular. Again in singular point there are two types, regular singular point and irregular singular. There are two types of singular points. Irregular singular. Again these singular points are depends on plus x plus qx depending on this p and q depends on suppose x minus a whole square into p of x plus and here x minus a whole square into q of x. If this is finite at that point, so it's finite at that point where x is equal to a, then we are saying that x equal to the regular singular, irregular singular. We are knowing in manner this is ordinary. Now I will extend this my theory. Here, suppose my equation having a regular singular point. Suppose d2y by dx2 plus q of x y by dx plus q of x is equal to 0. This is my differential equation. This equation having singular point at, I will say, x equal to 0. Then how to find out solution? Then this new method is called Frobenius method. Use here. Now what is that? This method tells that if x equal to 0 is regular singular point for our given equation, then solution is write the solution as y equal to suppose something x raised to power m into a0 plus a1x plus a2x square and so on. Or I will write this is function n into x raised to power m plus n equal to 0. This is our solution. Now remember this, if x equal to 0 is a regular singular point, then we can find our solution by using Frobenius method. Now here in this method again, how to find out solution? To find solution, again we have to find out y1. Y1 is again n equal to v m plus n into x power m plus -1 y2 second derivative n into m plus -1 n into x raised to m plus n minus 2. If we are putting all these equation, then equation 1 we can put all these equation in equation star, then equation star get in this equation star m value. How to find out this m value? Then the coefficient of lowest terms of x we'll find here value of n to find value of m. Again, already we have this y1 and y2. We are putting these values in equation star. Now our aim is to find out value of m. If we are putting y1 and y2 in star, comparing coefficient of equating or comparing coefficient of lowest power of what we have to do here, comparing coefficient of lowest power of x, and again this is identical with 0. Comparing here because right hand side is 0. We are comparing with 0 and we get a quadratic equation and get quadratic equation in m, and we are getting m having quadratic equation in m. That means we are getting m having two roots. M having two roots. Now using this nature of our roots, if this m are we are having m1 and m2 are, and if these roots are distinct, in particular cases they are distinct, and if for my solution is, we can write here solution as y is equal to some constant c1 into y value at m1 plus something constant y value at m1. So these roots are distinct, and again this is not differing by integer. Particular cases are there. I will discuss particular cases with example. And if roots are equal, then here m1 equal to m2. This case is there, m1 equal to 2. Then we can write the solution y is equal to c of y into m1 plus c2 into partial derivative of this y with respect to m at this m. In this case, we are getting solution. This solution if roots are distinct, again not differ by integer, roots are repeated, then we can write. Okay, I will go towards example. Only remember here our equation having a singular solution at x equal to. We will solve or find series solution x square into y by dx2 plus x into dy by dx plus x square minus m square into y. This is my equation. I will say this equation first. We have to solve this equation. Now here clearly x equal to 0 is a singular. Okay, this x equal to 0 is a singular point. Therefore, what we have to do? X equal to 0 is a singular point. Then which type of solution we can write here? In this case, we can write our solution by using Frobenius method. Now this solution is here y is equal to x into n into x raised to power n minus 1. write as by Frobenius method. Solution is y equal to summation n. Instead of n, I will pick another n already here. Therefore, I will write here as r equal to 0 to infinity ar into x raised to power m plus r. This r is a dummy indices. Here anything here. I'm not using n because n is given now. Now I will differentiate this two times. Y1 equal to summation r is equal to 0 m plus r into the power m y2 equal to summation r equal to 0 to infinity m plus r into m plus r minus a r into x raised to power m plus r minus 2. Isn't it? Okay. I will put therefore equation star becomes 1. Becomes what we are getting here, this equation 1, this is x square into y2. Here, this is an equation. X square into y, second derivative. What is y2? Summation r equal to 0 to infinity m plus r minus 1 into m plus r, right, into a r into x raised to power m plus r minus 2 plus x into summation m plus r into a r into x raised to power m plus r minus 1 plus x square minus n square into y. Y is summation ar into x raised to power m plus r. And I will multiply by this x square term. I'm multiplying this square to this bracket, this x to this bracket, and I'm multiplying this, both these terms to our square. Therefore, this summation becomes r equal to 0 to infinity m plus r minus 1 m plus r a r into x raised to power m plus this term. Now I am writing this term. This term becomes summation m plus r into a r into x raised to power m plus r equal to plus. Now I am multiplying this x square to this whole bracket. Becomes summation r equal to 0 to infinity a r into x raised to power m plus r plus 2, isn't it? Here, x square and m plus r minus m square into summation ar into x raised to power m, which is g. R varying from infinity. Now see, if powers of r are same, then we can collect in one bracket. Then we will simplify. If we'll observe, then we'll get here this power of x is m plus r. Here power of x is m plus r. Here power of x is m plus r, and r varying from infinity. They will, therefore, I will add all these terms togetherly. Therefore, we get summation r equal to 0 to infinity. I will write here coefficient of first term. This is my coefficient for first term. This is coefficient for second term. AR is now again common. Here coefficient. Here coefficient we have to take minus. I will write in m plus r minus 1 into m plus r plus m plus r. Now here is minus n square. Minus n square AR into x raised to power m plus remaining term is summation AR into x raised to power m plus r plus r is equal to 0. Simplify this bracket. Now here r plus 1 and r plus 1. Take common r plus 1. Happen r equal to 0 to infinity. Bracket we are getting m plus r term is common. Then in some bracket we are getting m plus r. Here minus 1 and this plus 1. Here. This is plus 1 here. We are getting minus 1. Therefore I will write this is minus 1 AR into m plus r plus second term as it is r equal to m plus r plus 2. Okay. Again I will simplify this. We are getting this as r equal to 0 infinity m plus r whole square minus l square. This term we are getting a r into x raised to power m plus r plus summation AR into x raised to power m plus r plus 2, which is equal to 0. Now this is interesting. I will write this here. R. Now after this, what we have to do? Method tells that compare a lowest degree term of m. Now here is x raised to power m plus r. Here is x raised to power n plus r. That means here, if I will put r equal to 0, then we will get a lowest degree term r, that is x raised to power m1. And here for this term we are not getting for second term. See, again here for second term we are not getting a lowest term, because if we are putting r equal to 0, we are getting m plus 2 term. If we are putting r equal to 0, we are getting m plus 2 term. Therefore I am putting here for this term, put m equal to 0, sorry, r equal to 0. I will put r equal to 0, we get lowest degree. Therefore for lowest degree term of m, I will write here, but or right here for lowest degree term of m, degree term equation 2, we have to put r equal to for lowest degree term of m, degree term of m in equation 2, we have to put r equal to 0. Therefore we get, if we are comparing, because right hand side is 0, therefore we get here I am putting r equal to 0, m plus 0 whole square minus n square equal to 0. Therefore we are getting here m square minus n square equal to 0. And from this we are getting, we have started here in our theory also. Then we are getting equation, then we are getting m, then we are getting m equal to 2 values. One is plus 1 and another one is minus 1. Only we are putting here, again here, A0 is also there, A0 into, but A0 is not equal to 0. This is our first element. We are taking this. So A0 is not equal to 0. Have this coefficient should be 0. And hence, we are getting M equal. These are the two values for this our term. And after that, what I will do? Again, I will equate next term. I will equate here next term here M x raised to power M by putting R equal to 0. We are getting M. Now I'll put R is equal to 1. Then we'll get a next lowest. Now next lowest term get by putting next lowest term of or M plus 1. We get by putting R is equal to 1. 2. Again, in equation 2, I will put R is equal to 1. What will happen? M plus 1. Again, we are getting this is M plus 1 whole square minus N square into A1. Now, no need to check next bracket. Because if we are again going toward this term, here is I'm putting R is equal to 1, then we can say M plus 3. We are not interested. Next lowest term is M plus 1. So I'm putting R is equal to 1. Now this 0. Now we are getting this term is equal to 0. From this term, we will conclude that this term M plus 1 whole square and N square into A1 is equal to 0. Here from this statement, we'll say that this A1 equal to 0. And we are not taking and this M plus 1 whole square minus square is not. This is not equal. Again, if you are taking this is equal to 0, then what will happen? M plus 1 square equal to N square. We are getting this term and this is not equal. Again, we are getting here M plus 1 or M plus 1 is equal to plus or minus. Then we are getting again different value for. Therefore, we must have this A1 equal to 0. Now here, when we are comparing next lowest term, then we are getting A1 equal to 0. Okay. From the first relation, we are getting this relation. Now, and we are knowing that these roots are distinct. If these roots are distinct, then we know solution in this equation also. After this, I will try to find out coefficient of x raised to power M plus R plus 2. Then what will happen? Equating coefficient of M plus R plus 2. We get of x raised to power M plus R plus 2 to 0. We get again from equation 3. If we are equating here, so in equation 2, if we are equating here this coefficient, in this case here, in this case we have to compare here M plus R plus 2. Then in this case we have to put R is equal to R plus 2. I'm replacing R by R plus 2 and then I'm comparing. That M plus R plus 2, we have to put R is equal to R plus 2. We have to replace R by R plus 2. Right here, this solution as M plus R plus 2. Next term, instead of R, I am replacing R plus 2 minus N square into minus n square into AR, but we have to write R plus 2 plus next term. This is your AR. Here is AR term, and here this term goes on changing as a R plus 2 plus AR is equal to. From this equation, we are getting a recurrence. This recurrence relation is, we are getting R plus 2. AR plus 2 is equal to minus AR whole divided by m plus R plus 2 whole square minus m plus R2 whole square into minus n square. Now, if I'll put R is equal to 1, 2, 3, and this whole for R is equal to 0, 1, 2, and so on. This is true. R is equal to 0. I will say that this is the recurrence relation. This is the recurrence relation for all R. Now, I will put here these values, but here A1 is 0. We are getting this equation when we are comparing by lowest term. Therefore, if I'll put R is equal to 1, P, that means we are getting odd number. If I'll put R is equal to 1, then we are getting here is A1. Okay. And if I will put R is equal to 3, again we are getting this equation in terms of A1. R equal to 5, we are getting all means odd numbers. If I will put, then I am getting here odd number, and